Hi everybody. I hope you can all hear me. I hope you've had a good day so far. So this is week 2, lecture 2. We're going to get right into some programming. Okay, let me know if I'm not loud enough or if the font's not big enough or something like that as we go along. Now, we've got some revision videos that are available, and here's a link to them. These go over topics that we've done, such as scanf, printf, if statements, while loops, which we're still in the middle of doing. They cover all the basics. So if you're interested, go have a look at those videos. The other thing I wanted to mention was that we've got help sessions starting next week, and we'll have the schedule out soon. So these are just optional sessions that you can drop into and get help from a tutor with, anything you're struggling with, if statements, setting up VLab on your computer properly, whatever it is, lab 2, etc. And I certainly recommend going to these things earlier in the term. Get on top of it while the help sessions aren't so busy. They get very full once the assignments are due. All right, so what did we do yesterday? We looked at, I hope you remember, but we looked at conditions and if statements, and we learned how to select chunks of code that we want to execute and sort of jump over chunks of code we don't want to execute in different situations. And then we looked a little bit at while loops. So we looked at infinite loops, and I showed you a simple counting loop. Mightn't have told you it was a counting loop, but anyway. Today we're going to cover more with single while loops, and we're also going to look at nested while loops. Then we're going to do something a little bit different and look at custom data types. And as usual, there's a link to the live lecture code so you can follow along or download it later and play around with it, whatever you like. So before we get into anything new, I do want to recap scanf return because, yeah, I've had quite a few people ask about it. So let's go into the code and have a look at this again. Apologies if you're sort of already on top of it, but I think a lot of people are still not sure. We only did it yesterday. So gosh, my drawing is worse than usual. My drawing of boxes. So in this program, we want the user to enter 2 integers and a double. And that's what we're telling scanf to read in, 2 integers and a double. And we're going to store the integers in X and Y and the double in Z. And we're also asking scanf to tell us how many inputs it actually read. So we want it to read in 3 things, but the user might not type in valid data, so scanf might not be able to do that. It's going to tell us how many things it actually read. So, for example, oops. For example, if I run it and I'm the user, let's start off, like, imagine they do type the right thing in. For example, they might type in 42 minus 19. Oh, my one key's sticking. And I don't know, 7.4. Okay, and then they press return. But what's scanf going to do? Scanf is going to look for an integer, and it reads along what the user's typed in. It sees 42, that's an integer. We're going well, we put it in the X variable. We're scanning along looking for another integer, if we're scanf, and we find minus 19. We can skip over spaces, that's fine. And we put that in Y. Then we're looking for a double. we scan along and we find 7.4. We put that in our Z variable. And then that's all we've asked Scanf to do. So even if we typed a bunch of other, if the user typed a bunch of other things over here, it doesn't matter. Scanf was asked to read in 3 things. It's read them. It's done, but it tells you that it read in 3 things. It returns a value to you. In this case, it'll be 3, and we're storing it in this particular variable. So once I press enter, this is what Scanf will do, and that's what all the variables will have in them. So when we get to this line here, it's going to print 3 inputs. That's how many things Scanf was successfully able to read. Then we can print them out and it works fine because we actually have values for X, Y, and Z. So this is how we hope it goes. Now, in reality, users sometimes, make typos or don't understand what they're trying to type in, or purposely try and type in rubbish too sometimes. So maybe the user doesn't type in the right type of data. Maybe they type in 87. Maybe they make a typo and actually accidentally type in A, whatever. What will happen this time is, well, Scanf is looking for an integer and it finds one, 87. It puts it in X. It's scanning along again looking for another integer, but the first thing it finds that's not a space is an A. This can't be an integer, so it fails, it stops, and it just returns the value 1 to say, I only read in one of those things that you wanted me to read in, and I store it in my variable. In this case, there's no value for Y or Z. They're still uninitialized. So when I press enter and Scanf does all of this, oh, I didn't type it in. Look, see, sometimes the user even forgets to run the program. Okay. We can't do anything about that though. So imagine I type it in when the program's running, press return. Well, Scanf tells us I only read in one thing, and that's what I print out. But when I go to print out my data, X, Y, Z, it crashes. Why? Well, we've got a value for X, but Y and Z are uninitialized. Now, this is not what we want a user to experience. Even if they did make a typo, they're not going to understand what all of this is. We want to realize that they've made a typo and print out something more meaningful for them. So what we can do, we can actually have an if statement to check if what they typed in was valid, and only then do we print it out. Otherwise, we give them an error message. Oops. Oh, my indentation's out here a bit. So that's what we're doing here. If we successfully read in 3 inputs, then we can print out X, Y, Z. Otherwise, we print out an error message. So in this case, we would know Scanf only read in 1 input successfully. 1 is not equal to 3. Let's try this again. 87, whatever. Okay, and instead of crashing, it can print something out to the user or, do whatever you like, but it doesn't crash the program. So we will be using Scanf return again today, later on, but that was just a bit of a recap. It's something new, something a bit confusing. Okay. Now the other thing that we did yesterday, we did talk about if statements. And remember, with an if statement, just the simple if statement, it checks this condition. If this condition is true, it executes the code inside these open and close brackets. If the condition is not true, it doesn't execute it. Now, does everyone remember what 1 means in this context? If 1, what does that mean? Well, I've got to change into the correct directory. Yeah, I can see a lot of people writing true, which is fantastic. So 1 means true. So it's checking, is 1 true? Yes, it definitely is true. So it's going to go into the if statement and execute the code, and it's going to print out, I love my COMP1511 1911 lectures, which is also true. All right. Now, if we change that keyword from if to while, instead of just doing it once if it's true, it does it while it's true. So as long as this condition is true, it's going to check the condition, execute the code, and jump back up the top and check it again. And it's going to keep going as long as this is true. And in this particular program, that's not so good because 1 is always going to be true, and we end up with this infinite loop. Okay? And you know, I think I said yesterday, you'll do this by accident as you're programming. We all do at times. And if you do it, just type Control-C to stop your infinite loop. All right. Yesterday, I also showed you a different infinite loop that we kind of fixed. So you can go back and watch the video to see that. So that's just our recap. Let's keep going. So when we've got an infinite loop, we're not controlling the loop. It's not being controlled at all. It's going forever. Typically, we want to control the loop so it ends at the appropriate time. There's 3 kind of different styles of loops that you might see. The most common one is a counting loop. And that's where you've got some kind of counter that's counting up to a certain limit. And that's controlling how many times the loop runs. So I think yesterday we did like 10 push-ups or something. So we had a counter for push-ups. When it reached 10 or 100 or whatever the limit was, it stopped. That's very common, and you'll do a lot of those. Sometimes we don't know how many times the loop will, we call it iterating each time it goes through. We don't know how many times we'll iterate because maybe it's going to be based on something that the user types in. So the user might be typing in data, and when that data reaches a certain total or something, then we might want to stop the loop. Or we might be getting random numbers from somewhere, or, you know, we might not know how many times it's going to iterate. And we call those just more generally conditional loops. I mean, all of our loops are going to have conditions in them, but these are sort of more general forms of a loop. Now, the sentinel loop is a special case of a conditional loop. So sometimes we tell the user, type in data or type in information, and when you want to stop and you've got no more data to type in some special value to let us know you're finished. So we might say, type in numbers and type in a negative number to stop. Or you might be playing a game and typing in AWSD or something. And when you want to stop the game, you might type in a Q to quit. So things like that, they might be a special value to signify, let's stop this loop. So we'll have examples. I'll show you examples of all these things. So this is the simplest one, I think. You might not agree, but this is a classic counting while loop. We've got a counter here, and we initialize it before the loop, and we've set it to 0. And in our while loop, we've got a condition that depends upon this counter. So we're going to keep doing this loop while counter is less than 5. And inside the loop, we've got a print statement. Here we go, loop-de-loop. And then we've got this very important thing, a counter. This updates, an increment to update the counter. because we eventually want this counter to get to 5 in this case so the loop can stop. So how many times do we think we're going to print out, here we go, loop-de-loop? Sometimes it can be a bit confusing when we've got a counter starting at 0. Sometimes people think, I don't know, does that mean it's 5 or 4 or 6? But yeah, it's going to end up printing this out 5 times. But yeah, it can be very confusing. People are often out by 1. Let's have a look at the code and run it. Okay. Now in here, I've just added this part here. So instead of just printing out, here we go, loop to loop, I'm going to print out the counter so we can clearly see what's happening. Oops. Yay. So it does print it out 5 times. So, you know, when we start, the counter is 0. And, you know, we get to this while loop, 0 is less than 5. So we print 0, here we go, loop de loop. Then we update the counter, and the counter is now equal to 1. And we go back to here and check this condition again. 1 is less than 5. So we go into here, we print 1 loop-de-loop, and then we increment the counter. And we do this again and again, 2 loop-de-loop. We increment, we print 3 loop-de-loop. We go through it again. We print out 4 loop-de-loop, or whatever. Here we go, loop-de-loop. And then at this point, when we increment it, our counter will be up to 5. So when we come back to here and we say, well, is counter less than 5? It's not. And so we stop. When we stop the loop, it continues on. Let me get rid of my scribble. It continues on from, you know, where this closing bracket is. It continues on and does the rest of the code, if there's any. So that's how our loops work. So what do you think if I, what do you think if I print this out? What do you think this is going to print? It's still going to print naught. It's still going to print all of this stuff it printed before. What's this extra line going to be? Yeah, 5, yay, the loop ended. So when the loop ended, our counter had a value of 5, and that's why the loop ended, and it'll print that out at the end. Okay, so this is a counting loop. Now, sometimes we might want to actually count backwards. We might want to start our counter at 5 and say 5, here we go, loop to de-loop, 4, here we go, loop de-loop, etc. What else would we need to change in this situation? So I want to count backwards. Yeah, now there's 2 things I need to change. So right here, if I just start at 5 and I try and run this, it won't do anything because the condition is saying less than 5. Yeah, we want to go back down to 0. So we might say something like, while counter is greater than 0. And sometimes it's hard and we get confused. Should it be greater than or equal to 0? But let's just try it out. Now, DCC is actually complaining to me and it's saying blah, 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 blah. Let's ignore DCC, which is something you should never do, but just to show you what's happening and why DCC is complaining. Yeah, we're incrementing our counter. It's starting at 5 and it's just getting bigger and bigger and bigger and bigger. And we're trying to, you know, stop when it gets to 0. So we've got to remember, which a lot of people have already sort of pointed out in the comments. Yeah, everyone's screaming in the comments. We need to subtract 1 in our loop now, okay? So eventually we do reach 0 and the loop can end. Yay! So with these counting loops, we can count backwards, forwards. We can go up by 2s or 10s or whatever we like. But the idea is we've got a set number that we're going to be going through. Okay, and you'll see lots of these and have lots of practice with these counting loops. Okay, now this next loop, this program is allowing somebody to track how much kombucha they've drunk in a day. I'm not going to name any names. And they've got a maximum, actually no, this is not, I don't really do this. There's a maximum of 2,000 mils of kombucha they can have in a day. And they're going to type in every time they drink kombucha how many mils they drank. And we're going to keep a running total of it. And this is something that's common to do, that users will type in data and you'll total it or do some sort of number crunching with it. So while the total kombucha is less than 2,000, we do this loop and we read in the current amount of kombucha and we add it on to the running total. We finish the loop when we get to 2,000 or more mils, and then we print out this warning at the end. Warning that, you know, you've had enough. Okay, so enter the number, enter the mils of kombucha. So, you know, if the user is drinking a small can, they might type in 250. And now the running total that we've got, because we're keeping track of the total each time we read something in, we're adding it to the total, which would now be 250. That's less than 2,000. The user can enter more. Maybe they drank another 250. And now we've got a total of 500. Mils, right? And then maybe they type in, I don't know, 1,000. Now we've got 1,500 as our total. And now maybe they type in, oops, 750. Well, once we add the 750 onto 1,500, we get to 2,250. That's over our limit and it stops. Okay, now we don't know that that's how many times the loop was going to execute. Maybe another time the user just says, I just drank 2,000 mils, and it stops after one iteration, right? It's depending on the data that we're receiving as to how many times it will go through. And we've got some condition managing it. Yeah, and look, we could do some, actually this allows me to say, I just drank 500 mils and I just drank minus 500 mils. You know, we could stop users doing stuff like that. Okay, so that's just a general conditional loop. Now, this next one, somebody just asked a question about, could we say max kombucha equals 2,000 instead of defining it? Well, these hash defines, we use them for constants. So style-wise, we like to put that up the top like this in capitals. And when we see it in our code, we know that this is some constant value. So we don't want to be saying max kombucha equals max kombucha plus 1 or anything like that. So you could get C to execute code like that, but style-wise, it's good to use these hash defines. Okay. Oh, it didn't stop at minus 500. I just stopped it myself. Yep. All right. I just killed the program myself. Let's have a look at this sentinel loop. So I'll go back and do that one before. Oh no, I won't. It's all right. Okay, while Sentinel, this one's typically quite confusing. So this is the one, let me just run it. This is the one that's letting a user type in data but then when they enter a negative number, it's going to stop the loop. So that's the user's signal to stop it. All right, how's this happening? Well, I've got my variable that I'm reading the data into, that the user's typing in. And then I've got this end loop variable. And this is, we sometimes call this a flag variable. We set it to 0 and it can control the loop. So while end loop equals 0, we keep doing this loop. We're reading in the data from the user and we want to stop the loop if the user enters a negative number. So we do this if statement. If the number they just entered is less than 0, then we go and set this end loop to 1. Why do we do this? Because if we set end loop to 1, this condition will no longer be true. End loop won't be equal to 0, it'll be equal to 1. And this allows us to end our loop. If they didn't type in a negative number, we're just printing out what they typed in. And we call these sorts of things where we have a variable where we set it to 0 and later to 1 or vice versa. We sometimes call these flag variables. So it's like waving a flag saying, you know, I want you to end the loop now, please. And that's when we set it to 1. So yeah, I'll just run it again. When we start off, end loop is equal to 0. So the loop is going to keep going. I type in a number, for example, 4, and it just prints it out. It's not less than 0. I type in another value. It's not less than 0. I type in 0, not less than 0. So we keep going around this loop. Once I type something like -5, that's going to be less than 0, and end loop now has a value of 1. So when we come back up to the top and we say, is end loop equal to 0? No, it's set to 1 and the loop stops. Okay. But basically, yeah, whenever this condition is no longer true, the loop stops. So however we're doing it, we're hoping that we're going to get to a condition that's no longer true so it can stop. Okay, and you're going to practice a lot of these loops, and the more you practice them, the more they'll become second nature. At first, you know, you've got to think really, really hard about them. And, you know, actually sometimes you still have to think really hard about them, but you'll become more used to them. Let's do an example. So in this example, we're wanting, let's read it. We want to write a program that reads integers from the user and sums them. Now that's a little bit like our kombucha one. It's reading in integers and summing them or totaling them. But we want to stop reading and totaling when we get a non-integer input. So that's a bit like the sentinel value. When the user types in something that's not an integer, we stop our loop. So let's try this. So I'm looking to add up numbers that a user's typing in. So I'm going to have a sum variable. I'm going to set it to 0. Every time I read something in, I'm going to add it to this sum. I also need something to store the number that the user is going to type in. And I'm also going to have like a flag variable so I know when to end my loop. And I'm going to do it similar to what we just saw. I'm going to say while end loop equals 0, keep going. And the basics of what I want to do is I just want to scan in a number and I want to add it to my sum. But I need to have some way of eventually stopping, right? So again, we're going to have to ask Scanf, did you read in a number or not? So I need to look at this return value from Scanf. So each time we go through the loop, it tries to read in another integer. If the user's typed in a letter or a character that's not an integer, this will return 0. If the user has typed in an integer, it returns 1. So now what we do is, if the user is still typing in valid integers, Scanf will return 1. Oops. And we're going to add it to our sum. Otherwise, what are we going to do? If the user types in something that's not a number, we want the loop to end. Our loop's going to end when end loop is not equal to 0. So if we set to end loop to anything other than 0, the loop will end. I'm going to set it to 1. Okay, that's not 0. So this is quite similar to the example we just saw, but instead of ending when we've got a negative number, we're ending when we've got a non-integer or non-numeric data. And as we go, instead of just printing out the number every time, we're adding it to a running total. At the end, we want to print out the sum. Okay. So I'll try it. And yeah, this is quite complicated, this example. It's putting together a lot of things that people find tricky, like the Scanf return value and a sentinel loop. Okay, so I type this in, Scanf returns 1 to say, yep, I got an integer. We add it to our sum and we keep going. End loop is still equal to 0. Same thing here. It adds it to the sum, adds it to the sum. I can type in negatives. That's not a sentinel value in this example. But as soon as I type in something that's not numeric, the loop will stop and it prints out the sum. Is that sum correct? Yep, I think it is. All right, so there are some examples of just single sort of while loops. And like I said, you're going to need to practice them and you'll have plenty of time to practice them throughout the course. But now I'm also going to talk about nested while loops. Okay, so we've seen loops, but we can also have a loop inside a loop. And this is where it starts getting quite complicated, right? But you'll all be able to do it, I promise you. Now, I like to think of it like a clock. Hopefully people still see clocks like this and not just digital clocks, but this is the hour hand. Now, by the time the hour hand moves 1 position, how many positions has the minute hand moved? Just a normal clock, forget computing. The hour hand moves 1 spot. How many times does the minute hand tick around? Yeah, a primitive clock. Yes, 60. So the actual minute hand in an hour will go around a whole time. It'll do a whole loop, and it'll be, you know, the minute will be changing 60 times for every hour. And then we've got the second hand, and that's going around 60 times every time the minute hand goes around once. Will not go, like, moves once. So that's sort of moving 3,600 times every time the hour moves by one, I think. And this is a lot like nested loops, right? I'm going to show you how we could write this kind of behavior with nested loops. Okay, so first of all, let's just start with just a single while loop. And this is a counting while loop, right? We've got a counter called hour. We've set it to 0, and we're doing our loop while hour is less than max hours. Oops. Let's change this to sensible values. 24 hours in a day, 60 minutes in an hour, etc. So hour is going to go from 0 up to 24, but not including 24. So it's going to be like 24-hour time. And we're printing the hour, then we're incrementing the hour. So if we run this, it's just going to print out all the hours in the day from 0 up to 23, like a 24-hour clock might. One thing that's not really related to loops at all, but I just wanted to do, there's some extra formatting things that we can use in printf. So if I want to make my numbers look pretty, I can do this. This is saying, make sure when you print it out to a width of 2, and if you don't have 2 digits, you know, pad it with a 0 in front of it. So see how, you know, the noughts, ones, and up to 9 is only 1 digit. If I do this, printf will format it so it looks like this, which is more like what you'd see in a clock. Okay, there's so many things you can do with printf. You don't have to know all of them, but this one can be handy. All right, so is everyone happy with this? We've got a single loop printing the hour for every hour in the day. But what we want to do is we want to create this sort of thing, like a clock that prints out the hour and the minute, and then the minute keeps changing. And then when the minute gets to 59, the hour ticks over and the minutes go back to 0. Okay, this is what we want to try and do. Now, sometimes people think, okay, I need a loop for the hours, and now I need a loop for the minutes. Oops. Let me go back. Okay. So, you know, they might think, let's do something like this. But then this isn't actually what we want. We end up with 2 independent loops, one loop that just goes and prints all of the hours, and then a separate loop that just goes and prints all the possible different minutes. That's not what we want. So what we want is every single hour, for every single hour, we want to print out every single possibility of minutes, right? So for every hour, we want to go and print out all of those 60 different minutes. So this is where we have what we call a nested loop. We've got this loop that goes through all the 60 minutes, and it's inside this loop that goes through all the hours. Okay, and when we do it, we just want to do our printf all on one line. So I'm going to move this into here. We're going to print the hour, then the minute. Let's try it, and this is what we call nested loops. Let's just put a colon character in here so it looks more like a clock. Yay! I mean, it's not printing it out in the right time frame, but this is printing out all the hours with all the possible minutes that a clock would go through. Now there's so many, it's hard to see the pattern properly. Let's pretend in our fictional world there are only 3 hours in the day and every hour has 5 minutes in it, just so we can kind of see the pattern of what's happening in the loop. Okay, so we can see over here that originally our hour is 0. Right, which is less than max hours. So we jump into the minute, we jump into the loop, and now we initialize our minutes to 0. Well, 0 is less than the max minutes. So now we're going to print out what we just printed out over here, this 0, 0, 0, 0. But we're still inside this inner while loop, right? We go back, we increment our minute. Our minute becomes 1. Oops. And we print out this line here. So our hour is still at 0, but our minute has increased to 1. And then our minute gets incremented to 2. 2 is less than our max number of minutes, which is 5. So this is going to print out this line here. Minute, we're still in this inner loop, gets incremented to 3. We print out this line, and so on. Our minutes gets to 4, and then we increment it and we get a 5. Now, once we get 5 in our fake world with a maximum of 5 minutes per hour, this loop is going to stop. And it's at this point that our hour gets incremented, and now we're finally up to hour 1. And what's really important is once we get back into this loop, before we start our inner loop again, we need to set the minutes back to 0 again, okay? And we go through it all again, okay? So this is a nested loop. Your life flashes before your eyes. Now, if you're super keen and on top of it, you can try and add another loop inside to get the seconds going, but I'm going to leave it at a loop in a loop today, not a loop in a loop in a loop. Okay. Now, this example is a bit different because here we've got, but this is another classic nested loop sort of situation. So often you've got like a board or like a board game or something like this, connect 4, noughts and crosses, whatever, or like a game where you've got like a land, and you know, you might have some gold here and a river over here or whatever. So you're often going through like a two-dimensional grid and printing it out or looking at it in some way. So we want to write code, oops, that can print out this pattern. Sorry, I'm getting distracted by the comments, some great comments. About could we put a delay? Yeah, we could, but not with what we're learning in this course. But yeah, you can. Okay, what am I doing? Oh, that's right. So we want to print out this pattern, this grid pattern. Now I've written some code already, which I think is fantastic, and it prints it out. Let's have a look at it. Now, what does everyone think about this code I've written? Do we think it's fantastic? Oh, we do. So the problem with this code is, like, this is for a 5 by 5 grid. What if this was, you know, 100 by 100? I would have to type that, copy and paste it. What if it was 1,000? What if I didn't know how big the grid had to be? What if the user was going to tell me, like, what if I was going to do a Scanf and the user would say, make it a 10 by 10 grid? Like, and I don't even know how big it is. I wouldn't even know how much to copy and paste and how much time in my life I was going to waste doing it. So we don't want to do this. We want to try and do this with loops. Yeah, exactly. Now, I don't want to jump straight into the whole pattern. Let's for now just try and get one row doing 1, 2, 3, 4, 5 to start with. And I'm going to call these columns. So I'm going to have a counter called column, and we can do just a counting loop. And I can say something like, well, while col is less than size, let's print out col . And, you know, let's see how that goes. So whatever, I've forgotten a few things, but why am I getting this horrible, basically infinite loop? I'm going to press Control C to stop it. I have not incremented my counter. Yeah, so I've got to say col equals col plus 1. Yay, it stops. I mean, it's not exactly what I want. I'm going to print a new line at the end. I really don't like it when it's on the same line as my prompt. Oops, print line. So let's try this. Okay. Again, not exactly what I want. I'm going to put a space in. Still not what I want. What do I need to change? I don't want to start at 0 this time. I want to start at 1, right? That's the first number I want to print out. Let's change that to 1. What's wrong now, though? Yeah, there's no 5. So I need to go one further. How can I do that? There's a few ways I can do it. Yeah, this is the way. There's always more than one way to do things, by the way. But what I'm going to do is I'm just going to change this to less than or equal to 5. So I'm not going to stop it at less than, I'm going to stop it at less than or equal. So now I've got my 1, 2, 3, 4, 5. Now I want to do all of this 5 times. I know how to write a loop that does something 5 times. So I'm going to make a loop and I'm going to call my counter row. It's going to be very similar because it's going to do something 5 times. What's it going to do 5 times? It's going to print out this one row of 1, 2, 3, 4, 5. And we're going to go through and do all of this, which prints out this 5 times. But maybe I've made a mistake. Oh, well, I've made lots of mistakes. Oh, it's because my 1 key is sticking. Okay, I have forgotten to increment my row counter. Okay. Okay. So this is another example of a nested loop, and you might want to maybe change the size to 3 and then sit down and trace through it and think, okay, now row is equal to 0 and col is equal to 1 and this is going to happen and that's going to happen. One thing I'll show you, which is a really common mistake, is putting this, see on line 22, putting this line up here. Why is this a problem? Let's run it. We get really weird output. But what happens is the first time round when we run it, row is equal to 1, col is equal to 1, and we print this. We increment col, it's equal to 2. We print this, we increment col, it's 3, it's 4, it's 5. Eventually, we increment col and it's equal to 6, and this loop finishes. And then we increment our row and we want to do row 2. Now, unfortunately, when we come in to do row 2, col is already 6. We haven't set it back to 1 again, so nothing happens in here. This condition is already false. So then we just get a new line, and then we go to the next row. Col is still 6. We get none of this. We get a new line, new line, new line, new line. So just be careful to reinitialize that inner loop. Yeah. And definitely try out all different things and play around with this stuff. Let me fix it before I forget and leave it like this. I've got one more nested while loop to do, but let's have a break. Let's come back at about 5 past. It's only about a 7-minute break. We'll come back at about 5 past and do one more example, then move on to something else. Okay, we're back from the break. So we've just done nested loops. And honestly, if this is like the first time you see loops and nested loops, you know, you don't just walk away being an expert in them after, you know, seeing them for the first time. You will need to practice them to really get on top of them in the labs. But we've just seen how to do a nested loop to print out something like this. Now, in this example, the one that we've done, every single time, every single row, we're going up to 5. We're printing 5 things. So every single time that inner loop is going up to 5. In this example, if we're in row 1, we only have one column, right? We're only printing out one thing. When we're in row 2, we're only printing out 2 things. When we're in row 3, we're only printing out 3 things. When we're in row 4, we're only printing out 4 things. When we're in row 5, well, we are printing out 5 things then. So in this case, we're not always printing out the same number of things when we're printing out like each row. But we've got a pattern. Often you'll be like trying to find patterns in things. So let's go to our code and see. I'm going to take this code that we've already written. I don't know why I've called this pyramid instead of like triangle or something, but here we go. Now this is our original code. And yeah, every time in this loop here, we're always going 1, 2, 3, 4, 5. We don't want to do that anymore. In row 1, we just want to print out 1. In row 2, we want to print out 1, 2. So the number of columns we're printing out is going to depend on the row. And we've got this row variable already. So when we're up to row 1, we're only going to print out 1 column, etc. Row 2, we're going to print out 2 columns. Row 3, etc. So now instead of this being a fixed size and always printing out the full 5 values, it's going to go up to whatever row we're up to. Okay. And this is a tricky example. So yeah, if you think this is a bit tricky, that's normal, but it's just a slightly trickier example. Okay, so that's it for today on the nested while loops. And don't worry, you'll see plenty of them. We've done the break. The next thing we're going to talk about is custom types. Custom data types. So I'll give you a moment to clear your mind from our while loops. Now imagine I want to store all this data. Now this is sort of a lot of variables. It's kind of hard to read and it just looks like a lot of clutter. And if we look a bit closer, these variables are sort of related. Some of them are related. So all of these variables are storing information about one particular person. All of these variables are storing information about another particular person. It would be nice if we could have variables that, you know, represent all the data about one particular person without having to have 4 different variables for that one person. If we could group it and package it up. And we can. Here's another example. I've got lots of these individual variables, and if we look closely, these are potentially related. Maybe this is all the data for one point, and maybe this is all the data for another point, or vector or coordinate or something. So we're going to learn how we can group the data that's, related into one variable. So far we've been using these built-in primitive data types like int, char, and double, and they can only store a single item of that type. We're going to learn about structs today. That allows us to design and define our own data types that can store collections of things, so more than one thing. So let's go and have a look at what we do. So the first step is we decide what we want our variable to be able to store. So I'm going to define a struct student, and I'm going to say, well, in every student that I want to store data about students. I want to store, we don't know how to store names yet, right? We haven't learnt that in C. So we're going to store their first initial, their last initial, their age, and their lab mark. Honestly, we don't usually care about your age, I promise you. Or do we even know it? But this is just an example. So I can define my struct student like this, okay? And we call these, the actual types of the data inside this struct, we call these members or fields. So we've got a char, and it's called first initial. This is one of the members or fields in our struct. Okay, once we define this struct, we're then able to use it as a type in our code. So I've defined this struct. Now I can create variables of this type. So this is defining our own type. Over here, we're using this type and asking for a variable of this type. And we've given our variable a name. And when we do this, like with any variable, we get a chunk of memory. But in this case, it's got to be big enough to store 2 chars, an int, and a double. And it's all going to be packaged up together. Right, and just to compare it to what we usually do, usually we might write type like int and the name x, where this is the type and x is the variable name. Here, struct student is the type and Brianna is the variable name. Okay, now once we've got this variable, we might want to put data in it. And this is how you can put data into your variable. You've got to use the variable name, and then you use dot, and then you give the name of the member. So we're saying, let's make Brianna.first initial equal to B, Brianna.last initial equal to K, Brianna.age equal to 21, Brianna.labmark equal to 9.9. So you've got to access these fields through this dot operator to get to the particular member or field. Okay. So let's do an exercise, right, where we can put this all together and do something, or just see how these structs work. So up here we've got our header comment, we've got hash includes, if we needed any hash defines we'd have them next, and then we've got our struct. Now just to sort of reiterate it, we're defining our struct here. This itself is not creating a variable. This is just a blueprint telling C, I'm going to start creating variables of this type. And this is what they look like, and you know, this is all the things I need to store in them. And here you go, you know what I'm talking about now. Now down here, if I want to declare a variable of type struct student, I can. I'm going to call the student Ryan. So this is the type, and this is the student's name. And I might say Ryan dot first initial equals, I guess, R. Ryan dot last initial equals, I don't know. And I don't have to initialize these in order, right? I could say Ryan dot lab mark equals 4.4. Ryan dot age equals, you know, whatever. Okay, so what I've done now is when I'm here, when I get to this line, I've asked for a chunk of memory. Here I've put in R for the first initial, Z for the last initial, 4.4, ooh. I don't know why I put quotes around 4.4, which is a float, a double, and 30 for the age. And this is all in one bundle for Ryan the student. But now that we've got all this, what on earth can we possibly do with it? Well, imagine Ryan at some point has a birthday and we want to increment the age. I have to go in and talk about the actual individual field inside this variable. I'd have to say Ryan.age equals Ryan.age plus 1. Okay. And then what if I wanted to print out this struct? Now, there's no percentage student sort of thing that Scanf, printf has built into it. It's not able to read our mind and know we're going to make a struct student. We just have to print it out ourselves. So if I want to print out this data, I'm going to have to do a printf, and I'm going to have to work out, well, I want the first initial, the last initial, the lab mark, and the age, or whatever it is that I'm wanting to print out about this student. And I'm going to have to say Ryan dot first initial, Ryan dot last initial. Apologies if anyone's called Ryan and I'm just saying your name over and over again. Ryan dot all age, Ryan dot lab mark. There we go. Now, we've now got a very wide line. We haven't talked about the style guide too much. That's in a lecture very soon, I think next week. But if you've done your 1511 setup, you'll have this vertical line that runs down here, because in the style guide, we say we don't want to go over this 80, width. So this should be 80 and I've gone past it. It's a bit too wide. So there's different ways you can space out your code, and you could go and look at the style guide. In this situation, I like to do this. Not everyone necessarily agrees on how to do these things, but we're going to follow, for the most part, what's in the style guide. So I like to do it like this, so I can see what I'm printing. And now it's within that range. So let's try this. Yay, all this work, and I've printed out RZ31 and 4.4. Any questions so far? Now somebody's saying respectfully, this feels more tedious than variables. And absolutely it does. Now, next week we're going to see something called functions, which means you'd only ever have to write this code once and then you could reuse it again later. And that makes this all feel a lot better. And once we use functions, we'll be passing data around and it's going to be a lot easier if it's in one nice package. So I completely agree right now. We haven't learned enough to make this seem like it's not really just annoying. Now, imagine I wanted to, you know, Ryan tells me, hang on, that's a typo. I didn't get 4.4, I got 10.4. And we want to update it. Well, I'm reading in, the lab mark is of type double. So I'm reading in a double. It would be Ryan.labmark. And of course, I'm doing Scanf. So I would need this ampersand to make that work. And for now, because we don't know any other better way, if I wanted to print it out, I'd have to, well, I'd either write this again or just copy and paste it to print it out. So here, that's Ryan's data, but I'm going to update Ryan's lab mark to 10.4. Wonderful. So that's just a bit of an idea of how we can use these things. Let's look at the other example where we've got some points, just to see something a little bit different. All right, I'll just go back to the code. So this time I've created a struct coordinate. Maybe coordinate's not the best name for it, but anyway, it's like an X, Y, Z. And I've created two variables, one that I've called point1, very creative naming, and one that I've called point2. So here I've declared these variables. They're uninitialized. They've just got uninitialized garbage in them. Maybe I want to read in the data from a user. So again, I could do a scanf. I'm reading in integers. And I'd have to say point1.x, point1.y, point1.z to read it in. I'm not doing error checking. And then again, if we wanted to print the point, oops. We do something like this. Actually, let's print it out so it looks like how we do points. Oops, I forgot my semicolon. What have I done wrong? Oh, I haven't used this particular variable yet. So it's complaining. Okay, so I can enter the data for a point. Woohoo! And I've printed it out. Now, if I wanted to make another point called point2 that has the exact same data, like I want a copy of point1 and I want to call it point2, I could actually use the equals operator. So, you know, if I've got something like int x equals 5, and I say int y equals x, Well, what's going to happen is X has 5 in it. Now we're going to put 5 in Y as well. We've got a copy. This is the way structs work. So I can say let me get rid of this. I can say point 2 equals 0.1, and that's going to copy all the data into my struct. Let's try it. Yeah, and it is tedious working with them at the moment, copying and pasting all this stuff. But yeah, we will solve that problem with functions next week. So let's do this. Let's type in data again. I've got 8, 6, 3 for no good reason. That's my point. I've printed out 0.1, and then I've just copied that data using the equals operator. All of those fields get copied over into 0.2, which now also contains 8, 6, and 3. Okay, and again, we can't do anything like, we can't do like maths on the whole point. I can't say anything like 0.2 equals 0.2 plus 1. That's not going to make sense. I would have to go in and, if I wanted to do maths on those coordinates, get the coordinates out, like access them individually, I should say. You know, I can do stuff like that. All right, so this is a little intro to structs. These are now just another sort of type at our disposal that we can use and design our own structs when we need to throughout the course. Any questions about structs? They seem weird at first because we don't know enough other C to show how useful these are yet. All right, there's one more thing I want to talk about today, but I might give everyone a break from my voice and do a Kahoot. Now, this Kahoot is just on basics and if statements. We didn't really recap ifs today, so this is going to recap some stuff to do with conditions. So get your device ready. Am I blasting this music at you? And don't forget, if you come first, second, third, or fourth or fifth, take a screenshot. And if you come into the face-to-face lectures, come up to, well, usually Rosemary has the bag of chocolates, and you can get, you know, 3 chocolates if you win, come one of those places. Or Skittles. There's usually Skittles and or chocolates. I'll just wait another minute or so for people to join. And yeah, tell me if you can hear the music and it's blaring. I don't know if you can even hear it at all. Okay, it seems to be flattening out a bit, the number of people joining. So I might start. Okay, let's go. Okay, well done. A lot of people got that, which is fantastic. We have the, it doesn't work well. Hang on. Yeah, we've got the type, then the name. Now, that declares a variable, but this part here is also initializing it. So if you wrote int mark, that's declaring a variable that's partly correct, but this part here equals 100 is initializing it. If you did this one over here, you're thinking about a constant. So the hash defines the constants that we don't change the values of, and yeah, the int mark equals 100, that's a variable. So that's just the terminology. Okay. Oh, what am I doing? Next. Very good. I'll get rid of this. And for the most part, the pictures I've got up are completely unrelated to the question, in case you're wondering. Yay, this is correct. Yeah, you've got to just always remember when we're doing scanf but not printf to have that ampersand. Okay. Next. I can't believe no one wrote to make our lives more difficult. But people did write to express that we are we are uncertain about if our code works. And most people got the right answer to execute different blocks of code for different conditions, different things for different situations. So that's if, and the thing that loops through the code, that's a while. Okay. Now these pictures are related to the question this time. Now this is what we kind of looked at yesterday. We've got, this is an OR, right? So we've got two parts. We've got this left part. There are 4 penguins, true or false? Oh, the picture's gone. There are 4 penguins, true or false? True. There are 4 penguins. Hopefully you realize these are penguins though, because they're kind of cartoons. But true, that's true. They are the same height? False. But when we're ORing things together, so when we have this symbol here, if we've got something that's true and something that's false, overall that's going to be equal to true. So with true, as long as one of these conditions is true, the whole expression is true. So because there are 4 penguins and that's true, it's not going to matter if they're the same height or not. The whole expression is true. So that's or. Okay. Any questions about that? So this is the new stuff. Or and can be confusing. Let's see how you go with the next one. Yay! Now this time it was almost the same. This time there are 4 penguins. True, there were 4 penguins. But instead of an or, we've got an and. They were the same height. No, false. Now when you're anding together the two true-false questions, they both have to be true for the whole expression to be true. So this is indeed false. Okay. Let's move on. Now we're going back to the pictures that aren't related to the question. Yay! So we can compare characters like this, and all the letters in the alphabet are in order. So all the lowercase letters are in order. So lowercase a is less than lowercase z. Great. Okay. Oh, I can't pronounce the leader, sorry. Wow, this is great. So again, we've got an and, but 7 is less than 15. That's true. 8 is greater than or equal to 15. That's false. They both have to be true if we've got an and for the whole expression to be true. Therefore, this was false. Excellent. Okay, we've still got the same leader. Okay, so yeah, we've got 7 is less than, I'm looking at these now thinking, is 7 less than 15? Like that's where my brain's at right now. True. Or 8 is greater than or equal to 15, false. But when we're oring two things together, only one of them has to be true for the whole expression to be true. So true is the correct answer. Oh, our leaders aren't changing much. Oh, this mean, horrific looking thing. Okay, so yeah, these ones are always confusing. We've got like a couple of these relational operators in here. So first of all, we do this inside thing. Is 5 less than 10? Yes, so we've got a true. Is 6 greater than 13? No, we've got a false. We OR them together. If I've got true or false, I get true. So this part in the middle is equal to true. But when I've got a not, that reverses it. So not true gives us a final answer of false. So this middle part, like this expression in brackets, was true, but not true gives us false. Okay. All right. So hopefully that's reminded you of some of these sort of relational operators. Okay, let's see who the winner was. I think that was the last question. Well done, Quick Falcon. Fancy Rabbit. And our amazing winner. And we've got runners up as well. Screenshot, if that's you, come and let us know. Get some chocolates or Skittles on next week on Monday. Okay. Stop. I'm just going to turn. Okay, there we go. All right, now don't get too excited. We still have a little bit more to do. So we've talked about structs, and we will use these a lot, I promise, in the course. Oh, great. Somebody here has won. Well, of course, someone here's won, but somebody has said that they've won. Very, very good. All right. Let's talk about enumerations. These are another type that we can sort of design and create ourselves. So enumerations allow us to assign names to integer constants. And this is about making our style better and making it easier to read and maintain our code. So I can say, and here the keyword is enum. Oops, I've leant on my laptop. There we go. We've got the keyword enum, and then we make up a name for the enum, and then we make up or define our constants that we're interested in using. So a good example is this enum weekdays. So we can define a type called enum weekdays, and the valid values for one of these variables when we create one is either man or chu or wed or thur or fry or sat or sun. So we can create variables that we can give days of the week to, that can store days of the week. Or, we could do enum months or enum colors or something like that, where we're listing out a list of sort of constant values. And by default, these enumerated constants will have values 0, then 1, then 2, then 3, then 4, then 5, then 6, etc. Sometimes we don't want those defaults. So down here we've got enum status code, and we're saying one of the values you can do is okay, but its underlying constant value is 200. Not found, its underlying constant value is 404. Now, this is very different to structs, because structs can store a collection of different things. If I've got, and I'll show you on the next slide. Here, I'm declaring a variable called day. It's of type enum weekdays. This variable can only store one thing. And the one thing it can store is one of these values, right? So I can say day equals sat, Saturday. And it's actually going to store the underlying, value 5, 0, 1, 2, 3, 4, 5. So I can only store one thing in my enum variables. but we enumerate all the possible values it could contain, right? So these are the only valid values we should be giving a variable like this, and it's just going to store one thing. Whereas structs can store a collection of different things. Now, unfortunately, we say day equals sat, and that's all beautiful. But if we're to go and try and print this out, unless we write our own if statements and say if day is equal to sat, print out Saturday, unless we do something like that, if we just print it out, it's going to print it out as, say, 5. And we'll see later how to deal with this sort of stuff and make them, again, a bit more useful than they seem right now when we don't know enough C to really put them to good use. The thing that people often do ask about, though, is, isn't this the same as hash define? And it's very similar to hash define because we are trying to define constant values that we can use. Let's go and have a look at this code. So here I've got my Enum weekdays, and this time I've set my day of the week variable to Monday, and if I print it out, it's going to print naught. Again, not so great. Like I said, if I wanted to print it out, I could say if day equals mun, printf Monday, else if, you know, day equals chew, printf Tuesday, etc. I'm not going to type that all in now. I could do that. That right now is going to be annoying. I'd have to keep copying and pasting that code all the time. We'll see next week a nicer way to do it. Now, why couldn't we just do something like this? Why couldn't I just say, well, let's use hash define. We already know that. I can't use the same name mun, chew, wed. So let's do Monday. Tuesday, Wednesday, etc. All right. Now, why is using this weekdays enum better than doing something like this? Well, if I want to create a variable with a day of the week using my hash define way, I could, but I could also, imagine I had other hash defines. I could easily say my day equals max kombucha as well. If I'm doing something with enums, it's nice, it's very clear what the suitable values are for any of my enum weekdays variables. And just say, I'm going to get rid of these hash defines. Just say I've got another enum called months, Jan, Feb, March, etc. I'm not going to type them all in. If I try and say day equals Jan, the compiler can try and help me and stop me doing something silly like that. Okay. All right. So when would I use hash defines? When would I use enum? Basically, Enum, if you've got a set of related values, like all of these days are days of the week and they're all related. So you've got a set of possible values that you might want to assign to a variable. And that having the, being represented by integer constants is appropriate. If you want to store gravity, you're going to need like a hash define for it. If you wanted to store like 9.8 or something, you'd use a hash define for that. Because when we use enums, they all get constant values. So anything where you're representing a double, you'd need a hash define. Anything that's a one-off value, we don't want to create enums with just random things like max kombucha, days in the week, seconds in minutes. Like we don't want unrelated things grouped together. So we've got two options now when we've got constants. We can either use hash defines or enums. And as we go through the course, you'll get a better handle on which is the best to use. All right, we've only got a few more minutes, but let's go and have a look at this Pokemon example. We're not going to finish it now. But for example, I could create an enumerated type called Pokemon type. And I could go and do something similar to this and put all the different possible types in here. Now, I can't remember all the Pokemon types, to be honest. I'm making this up. What else is there? Water, ice, grass, fairy, dragon, flying. Okay, I'm not going to get them all. It's too many. Terra, steel. Oh, I'll add ghost. Oh, poison. Okay, I've missed out some of them. I'm sorry. There's too many. Now, the idea is, let me talk about what we mean by a custom data type. So basically in C, we've already got an integer. Now, when I declare an integer variable x, I've got a whole set of possible values I can assign to it. And it goes from some really negative number up to some really big number, but I can assign it any of those values. Okay? And one possible value I could put in is something like this. And the same with double. There's a set of possible values I could give it, and this is one of the legal values. I'm now defining my own data type, and I'm calling it Enum Pokemon. It's not built into C. C does not have any kind of inbuilt Pokemon type. I'm creating my own type, and the range of different values it can take on, I'm defining it. I'm saying, well, if you've got a Pokemon type variable, you can give it these different values. Okay? You can't give it the value 4.3 or something like that, but you can give it the value ice or grass. So you're defining a custom data type. You're saying what the name of this new type is. You're defining what possible values this thing can have. Now, our enums can only store one thing at a time, but these are all the possibilities that it could store. And I'm enumerating them, I'm typing them all out. We can see what all the options are. Hopefully that makes sort of sense. But the reason we do it is we want to be able to have sort of constant values that represent things in a way that it's easy for us to type in, manage, and read. So that's all we've got time for now. Next week, we're going to make a Pokemon struct. like we're going to design one or define one, and that's going, every Pokemon will have a type. And you know, other things. You'll have to tell me what to put in it. All right, that's all we've got time for today. Yeah, it takes a while for people to sort of understand why we would bother doing this enum, but we're going to keep doing it. We'll do our Pokemon example next week, and Pokemon enums aren't included in the week 2 lab. They'll be included in future labs though. Okay. All right. Thank you so much, everybody. We've covered a lot today, from like while loops, nested while loops, structs, enums. It's a lot. We're going to go through these enums and structs again next week. All right. Have a great week. And yeah, thanks for coming. See you later. Thanks, everybody. Thank you. Bye.